In this chapter, what we're going to be talking about is we're going to be talking about particle and wave duality. How we can look at things such as particles, say electrons, as waves, and as we look at certain waves such as light in terms of particles, which would be photons. All right, so for the first question, it states as such. The surface temperature of the sun is at 5,770 Kelvin. Determine A, its wavelength at the peak emission, and B, the surface brightness per square meter. So for part A, the equation we're going to use is lambda max is equal to 0.29 centimeters Kelvin divided by temperature Kelvin. And so we simply plug in our temperature Kelvin into that. This becomes 0.29 centimeter per Kelvin divided by 5,770 Kelvin. The units of Kelvin cancel, and this gives us a value of 5.03 times 10 to the negative 5 centimeter. Or we can say that this is going to be equal to 503 nanometers. For part B, it asks for the surface brightness in per square meter. So for part B, we're going to deal with the intensity is equal to the power over the area, which is equal to sigma times the temperature to the fourth power. Now sigma is going to be a constant, and that sigma constant is 5.67 times 10 to the negative eighth, and this is going to be units of watt per meter squared Kelvin to the fourth. And so we multiply that by our temperature to the fourth power, which is 5770 Kelvin, so 5770 Kelvin to the fourth power. And the number we get for this is 6.285 times 10 to the seventh watt per meter squared, because the units of Kelvin to the fourth will cancel with the units of the Kelvin here. Remember, this is going to be to the fourth power. So this is a tremendous amount of energy per square meter. And to give you an idea, this is about what 1 meter is. So you would have to either go a meter back or a meter towards you, or you could go a meter up. So we could go this height, about the height of this board, which it's going out of your frame, to this length. And so this is a tremendous amount of power per square meter, and we can determine that based on the temperature. If you have any questions on this, please let me know.